9.4 is moving on to graphing ellipses, which ellipses are really just kind of a squished circle. We can have ellipses that run vertical or run horizontal, like you see here on the screen. If it runs vertical, like the one on the left here, then we say that the major axis is a vertical major axis. So what we're talking about is, in this case, the y axis is our major axis because it's the longest one. And then the x-axis is our minor axis because it's shorter running through the circle. Right, so the longer side or the longer section of the circle is going to be your major axis. Over here on the right hand side, when it's running horizontal, then our major axis, the longer side to side here through the ellipse, is horizontal. And so in this case, it's our our x-axis here. We're also dealing with the standard form equation of ellipses that have the center as their origin, again, just like we did with our circle. So when you have a major axis that is vertical, it takes this standard form equation right here, okay, where your a squared term is going to be underneath your y squared term. Over here, if the major axis is horizontal, then you have the reverse scenario. So in this case, your a squared is underneath the x squared term. But in order to have standard form for these ellipses, you need to make sure what you're looking for to see if it is in fact in standard form is if on the right hand side of the equation you have the value of 1. So we need to make sure that we have the value of 1. If we don't, then we need to solve until we have that situation. So if you see over here, we're going to do number 1 and 2. They're both in standard form because on the right hand side we have a 1. In number 4 down here, 5 and 6, none of these are solved for a 1 with the 1 on the other on the right hand side. So before we can do anything, we're going to have to divide through. Like in number 4, we'll have to divide through by 36, the entire equation, to get 1 over on this side. So 4, 5, and 6 are not in standard form. 1, 2, and 3 are over here. All right, a couple of more new vocabulary words. Well, we know what vertices are. They are the points in this case that in a circle they were all equal because the points are equidistant from the center of the circle. In an ellipse, our vertices are going to lie on the major axis here. So your vertices on this vertical ellipsis are here. These are your vertices, and then on this one, these are your vertices over here. All right, so you're looking for the points that are lying on that major axis. The co-vertices are the ones that lie on the minor axis. So that's something we didn't have in the circle. We didn't have co-vertices. All right, so those can be marked like that. And then in an ellipse, you're going to have two focuses. The plural for focuses is really foci. And so that's what this word right here is. So you're going to have two, and we can determine those with this equation right here. C squared equals a squared minus b squared. Your c squared will be the value that gives you the foci. So let's take a look at number 1. We're going to graph the equation. The first thing we need to do is identify our vertices, our co-vertices, and then the foci of the ellipse. So we're going to double check, make sure it's in standard form, which it is. Then we're going to find the vertices. Now, the vertices are going to be the points that lie on the major axis. The way we're going to decide which one we have, whether it's vertical or horizontal, is by looking at the denominators. Your a squared is always going to be the larger denominator. So in this case, the 36 is my a squared, the 16 is my b squared, and I'm just going to write them under there so I don't forget. So if you come back over here and look at our standard form equations, when we have the a squared term underneath the y squared term, that means that our major axis is running vertical. So this is going to be a vertical um, ellipse. That also means that our vertices are going to lie on that major axis. So in order to find our vertices, we're going to solve for a. All right, if our a squared is 36, then our a value, and again, we're only going to use the positive form of it because we're talking about length, our a is 6. Okay, so what that means is we're going from the center here, we're going 6 units up, 2, 3, 4, 6 there, and 6 units down here. Okay, so those are our vertices. They asked us to identify the vertices. If they want to know the coordinates for the vertices, then we could just write it out in coordinate pair at 0, 6 and 0, -6. All right, so then now we need to find the co-vertices, and so we'll do that by finding our b value. So our b squared equals 16, which means our b equals 4, and so that means I'm coming out, this is my minor axis, so I'm going to come out 4 units on either side of the origin, because that's the center of our circle in this case, and then if I were to write them out as coordinate pairs, we would have that at 4, 0, and -4, 0. All right, and then the last thing we need to do is find the foci. So we're going to use that equation down here, c squared equals a squared minus b squared. All right, so if we come over here and actually let me move into this space. C squared equals a squared minus b squared. Right, so I don't know c squared, that's what I'm solving for, but I know my a squared term is 36. I know my b squared term is 16. So c squared equals 20. And that will be when I plug that into, actually, I'm just going to do prime factor this. All right, so remember we prime factor tree. We can pull these 2's out one time because it's a square root, and that'll be 2 square roots of 5. So these are our foci. And that would be our plus minus for this because we're going to have one on each side. Okay, and now I'm going to graph that by connecting my dots and as smooth of a circle as I'm able to do. And I'll plot in my foci. That says about 4, I think it's about 4.5, so I'm going to put that here. Label that with an F, and same here. Okay. All right. So let's move on and try another one. So let's look at number 4, because number 4 is not in standard form. So since it's not in standard form, we need to divide through by 36 the entire fraction. I'm sorry, the entire equation. So because our goal is to get a 1 on that right-hand side. So if I divide by 36 on the right, I've got to divide by 36 on the left. So here I've got 2 fractions. You know, I need to say 9x squared divided by 36. If I reduce the 9/36, I'll get x squared over 4. And then I'll do the same thing here. 4y squared divided by the 36 will give me y squared over 9. And then I have 1 here. So now it very much looks like the problem number 1 on the top. All right, so now that we have it in standard form, I'm going to come over here and look at what I have going on here. I've got the denominator of 9 is larger. So that means this is going to be my a squared. So 9 is my a squared, 4 is my b squared. If I look over here at the 2 standard form equations, I can see that again, I've got my a squared under the y squared term, and so that's going to mean my major axis is going to be vertical. So a squared is 9. That means that a is 3. So from my origin, I'm going to go up and down 3 units. And then my b squared is 4. So my b is going to be 2. I'll go right and left 2. So my vertices are on the major axis. These points here, co-vertices are here. If I were asked to write out the coordinate pairs, then I could do that. Vertices at 0, 3 and 0, -3, and then my co-vertices at 2, 0 and -2, 0. All right, and then I'm going to find my foci by taking a squared and subtracting b squared from it. So a squared was 9, b squared was 4, so that gives me 5. A c squared, that is 5. Actually, hang on a second. Yep, that's right. Thought I made a mistake there. So my c squared is 5, which means c is going to be plus or minus 5. So those are my foci. If I were to graph those, we would have that at a little bit over 2 on each side. So there's one foci, there's the other one, and remembering that those need to be on the major axes. So this again is a vertical major axes, and then we'll connect our dots together here to give us our ellipse. All right, now moving down to number 7, we've got some information they gave us about the vertex of the ellipse and the co-vertex. So, and they're telling us as well that the center is 0, 0. So from that information, we can determine the major axis. If the vertex is at 3, 0, and the co-vertex is at 0, 2, that means that our vertex here is on the horizontal axes. So if I draw that out, just to give you a little visual here, that means that here the longer side is at 3, 0, which means the other vertex is down here at -3, and then our co-vertexes are at 2 and -2 on the y-axis. So this you can see if we were to draw an ellipse in at these points here, we're going to get a horizontal running ellipse, which means that our major axis is running horizontal. If our major axis is running horizontal, then we have a situation where the a term then is under our x squared. It's the longer, the a squared is always going to be the longer line, the major axis. It's going to be the denominator that's the largest, and our b squared will be under the y squared. All right, so we're going to need this form of the standard equation. So we'll take our vertex is at 3, that's our a, and we'll square it. And then our b is that value of 2. We'll square that. And we will end up then with a standard form for this equation of x squared over 9 plus y squared over 4 equals 1. All right, in number 8, we have the opposite situation. Here we can see that our vertex, which is going to be what lies on the major axis, is at 0, 5. So if I sketch that out, then that means we've got a vertex up here at 5, 0. We have another vertex down here at -5, or I'm sorry, 0, 5, and then 0, -5. And then our co-vertices are going to be here at 1, 0, and -1, 0. So I'm looking at a thin ellipse that's running vertical. So if our major axis is vertical, then this is when we have our b squared term is under x, the x squared term, and our a squared term is going to be under the y squared. That'll be equaling 1. All right, so we'll take our b squared and square it. So 1 squared just gives me 1. And then my a squared term, or I'm sorry, my a term of 5 is going to be 25 once I square it. And so then this becomes my standard form for that equation for number 8. So now on the back side, on number 10, they're giving us a vertex and the focus. And so from there, we can do the same thing. We just have different information, so we're going to have to go about it a little bit differently. If our vertex is at 0, 4, that means that the vertex is on the y-axis. So because of that, that's our major axes, and so this is going to be running vertical. This is a vertical circle, ellipse. So that means that my a squared term, my major axis, is going to be underneath the y squared term. Okay, so now they gave me the coordinate for the vertex, which is 4. So my a is 4. My a squared will be 16. So I've gotten this far. The difference here is they didn't give me the co-vertex, so I don't have my b value, but they did give me the focus. And I know that the equation that correlates the focus with the vertex and the co-vertex is this right here. So they gave me my focus. That means they gave me my c. So if I take the c value and I square it, I have my a squared. My a squared is 16, so I can go ahead and write that in. What I don't have is the b. And so this is what I'm going to be solving for. I'm going to be solving for my co-vertex coordinate right here. So 2 raised to the second power is 4. The square root of 3 raised to the second power is 3. So I have 4 times 3 on this side. All right, so I end up with this right here. When I've done all the algebra, subtracted the 16, divided through by -1, which I'm not going to bother doing that right now on the video. I know you can do that part. I'm going to end up with a b squared of 4 and then a b value of 2. Okay, so now I can see that my b is 2. So when I plug that back in to the standard form equation and square it, it'll look just like this. Okay, so depending on the information they give you is going to depend on which way you're going to do this. You're going to just go about it a little bit differently if they've given you a vertex and a focus. You could do the same thing if they gave you a co-vertex and the focus. You would just be solving for a squared and for your a value rather than your b squared. Okay, so that would look like the number 12 here. So depending on what information they give you, you've got to determine your steps to solve for what you need. All right, and then moving down to 13 through 15, they now say they've given you equations of a parabola, a circle, and an ellipse. So they've added the ellipse in. Let's just go through and talk again about how you can tell which one's which just from the equations. Here you have an x squared term, but the y is not squared. So this cannot be a circle or a parabola. Both of those require both terms to be squared, so this is going to be your parabola. Here we have an x squared and a y squared, and the coefficients are the same. So because the coefficients are the same, we know we're going to end up with points that are equidistant from the center of the circle. So this is going to be a circle. This one we have the x squared and the y squared term, however, the coefficients are different on them. So that means that there's going to be a major axis, one that's a little bit longer than the other axis, which would be the minor one. So that's how we know this one is going to end up being an ellipse. So if we go through our steps on number 13 for solving to graph a parabola, this is not in standard form. First thing you have to do is make sure that x squared term is solved for. All right, so because it's an x squared and not a y squared, we know it's either going to open up or down. The standard form for this equation for an x squared is x squared equals 4py. That means my 4p equals that -12 coefficient on the y. So my p is -3. Since my p is less than 0, I know that this parabola is going to open downward. All right, my vertex is going to be at 0, 0. And when I plug in a couple of points, really, I just really need one. I'm going to take -3 for y, because if I multiply -3 times -12, I'm going to get a positive 36, and that is very easy to do in my head. The square root of 36 is going to give me an x value of 6. Okay, once again, if you forget the vertex is at 0, 0, just plug 0 in, and when you do that, you'll see pretty quickly that your x has to be 0 as well. All right, and so then I'll plot 6, -3, which I think is about right here. And then this is a parabola, so this is my axis of symmetry, the y-axis. So I'm going to mirror over to get my third point. And, oh, that's a little off. I have to go over a little more. Okay, and then I'll connect those. All right, remember again, just as a reminder, the p value is your focus. So that's on the inside of the parabola. So that would be this right here. Your directrix is going to be exactly the same distance away from the vertex. So that will run up here at a +3 for your directrix. All right, so we've got a circle that is not in standard form. So we want to divide through by 3. I'm going to factor out that GCF of 3 first, just so we can see it a little bit better, and then we'll divide both sides through by 3 to get x squared plus y squared equals 16. So the standard form for the equation of a circle is x squared plus y squared equals r squared. So our r squared is 16, which makes our r 4. Our center of our circle is 0. And so we're going to come out on each side and 4 units, and then we'll connect for that circle. Right, and then the last one, the ellipse here, is also not in standard form, like we already talked about. Standard form for the ellipse, remember again, means that we have to have a 1 on the right-hand side here. So where over here we wanted our x squared and our y squared terms to be solved for by dividing through by that 3. Now we need to make sure that we have a 1 over here on the right-hand side. So in order to do that, we are going to divide both sides through by 96. That'll give us a 1 on this side, which is what we need. 6x divided by 96 is going to give us x squared over 16. 8y squared over 96 gives us y squared over 12. So now it's in standard form. We can see that our denominator in the x squared term is larger than the denominator in our y squared. So this right here, this 16, is our a squared, and this is our b squared term. Okay, so since our a squared term falls under the x squared, that means we have a horizontal major axis. And so when we solve for a, we're going to get 4. So that's going to be since the major axis is our x-axis, it's going to be lying here on the x-axis at 4 and 4, 4 and -4. And then our b is the square root of 12. All right, and when we factor that out, we'll get 2 square roots of 3, which is about approximately 3.5. So that will lie on the minor axis here and here. It's maybe a little bit off. Let's go up a little higher. And then we'll connect those as well. All right, if we had needed the foci, then that's when we would use our c squared equals a squared minus b squared, but we can graph the basic function without that, the basic equation, not function. So when you get to these problems where you have to determine which type of equation you have, make sure you go back first and look to see which terms are squared, and then after you've determined that part, narrowed down between parabolas and or a circle ellipse, then you go back and look at those coefficients on the x squared and the y squared terms. And if they match, if they're the same, it's going to be a circle. If they're different, it'll be an ellipse. And then you can go from there to graph following the basic steps and principles we've talked about.